Today we're doing 7th grade math, chapter 4, lesson 4. We're adding and subtracting unlike fractions. So building on the last video, the only way to add or subtract fractions is to make sure the denominator is the same. In order to do that, we have to convert. So our example here is 1/8 plus 2/4. 1/8 plus 2/4. Now, there are two ways of looking at this. One, I can convert down. So I could make this 8 become 4, but unfortunately, I have a 1 in the numerator spot. In order to make that 8 become 4, I'd have to divide it by 2. I can't divide 1 by 2. Therefore, I'm not going to be able to make this a denominator of 4. So no scaling down on this one, but I can scale up. I can make that 4 become 8 by multiplying it by 2. Whatever I do to one number, I have to do to the other. So both of these are going to be multiplied by 2. 4 times 2 will become 8. And 2 times 2 will become 4. Now that I have like fractions, common denominators, I can add numerator and numerator. This will become 5/8. Because again, you have 1 out of 8 and you have 4 out of 8. We do not make this 5 out of 16 because we do not multiply, add, subtract anything with the denominators. The denominators stay the same. The numerators are the only ones going through the mathematical practice. Therefore, 1 plus 4 equals 5, and this is simplified because 5 and 8 have no common factors. My answer is 5/8. So again, unlike fractions are fractions that have different denominators. Example that we used was 1/8 plus 2/4. Denominators are different. We are going to find the least common denominator, the LCD, in order to be able to solve this. We converted 2 and 4, or 2/4, to become 4/8, just like it says here. Then I could do 1/8 plus 4/8, which equaled 5/8. Again, with the simplify or die, 5/8 is simplified. Therefore, our answer is 5/8. Now remember, this goes both for adding and subtracting. So now we have a negative 2/3 minus 1/2. Negative 2/3 minus 1/2. I can't do anything because these two are not the same. Therefore, I am going to find the least common multiple between 3 and 2, which is going to be 6. If I count by 2s, it's 2, 4, 6, 8, 10, 12, and I count by 3, it's 3, 6, 6 being the first one that they both have in common. Multiplying these both by 2 and multiplying these both by 3 in order to make 6. 3 times 2 will be 6, and 2 times 2 will be 4. So my fraction becomes negative 4/6. On this side, 2 times 3 will become 6, and 1 times 3 will become 3. So basically what I have here now is I will have a denominator of 6, but now I have negative 4 minus 3, which is indicated, with that there, up here. Negative 4 minus 3. Again, this is the same thing as saying you owe somebody $4, now you owe somebody $3, you owe a total of $7. Negative 7/6. This is the first part where we're going to see something called an improper fraction. When your numerator is larger than your denominator, you have an improper fraction. Now, looking over here, we have negative 7/6, just like we said, and we're going to simplify. In order to simplify an improper fraction, we do numerator divided by denominator. Negative 7/6. So we're going to do 7 divided by 6. 6 will go into 7 one time. That will be 6, and I'll have 1 left over. Therefore, 7/6, or I should say negative, because it's still negative 7/6, will become 1 and 1/6. 1 and 1/6, but remember it was still negative, therefore it's a negative 1 and 1/6, and I don't know why it turns that into a weird little triangle. Negative 1 and 1/6. And if we look over here, that's exactly what we got. So something else to add to your notes. Again, we did this last year, but remember, anytime your numerator is a larger number than your denominator, it needs to be simplified and it will become a mixed number. You just divide numerator by denominator, whole number, numerator, denominator. So it'll become 1 and 1/6. And it keeps pulling over to that side. Another example is 3/4 plus 1/5. 3/4 plus 1/5. Now, sometimes it's just easier to multiply the two. If I look at multiples of 4 and 5, we're not going to get a common until we get to 20, which is 4 times 5. So sometimes it's just easier just to multiply it by the opposite number. So we're going to multiply these both by 5, and then these both are going to be multiplied by 4. When I multiply 4 times 5, I'm going to get 20, as previously stated, and 13 times 5 will give me 15. 5 times 4, again, will give me 20, and 1 times 4 will give me 4. Therefore, we have 15 plus 4. It will give me 19 out of 20, and that is simplified. They have no common factors. My correct answer is 19/20. And if we look here, that's exactly what we got here. 19/20 is simplified. All right, let's do some of these problems, and we are going to convert. We have 3/5 plus 1/10. 3/5 plus 1/10. Now, in order to do this, I need to have common denominators. I can totally try to make 10 down to 5 by dividing by 2, but this one won't let me do that. Therefore, I'm going to go ahead and scale up this 5 to become 10 by multiplying them both by 2. 5 times 10 will become, 5 times 2 will become 10, and 3 times 2 will become 6. When I add them straight across, I'll get 7, and the denominators stay the same. And 7/10 is simplified, because 7 and 10 do not share any common factors. Next question. Negative 5/6 plus negative 4/9. 5/6, negative 5/6 plus negative 4/9. If I remember that correctly, yes. So 6 and 9. They both have a common factor of 3, if I can get them down to become 3, which is not going to happen. In order to do that to 6, I have to divide by 2, can't divide 5 by 2, and then in order to make 9 3, I have to divide by 3, can't do that to 4. Therefore, we're going to look for the least common multiple between the two. Now, looking back at our notes, least common denominators of 3 and 2 were 3 and 2. Multiply them together. So again, another way to do this is to do prime factorization. 6 and 9. Actually, no, not prime factorization, because it's going to find the least common. So ignore what I'm saying. In order to find the least common multiple of 6 and 9, we're going to count 6, 12, 18, and I know 9 will be 9, 18. So 18 is going to be that number that we are going to try to convert up to. In order to make 9 18, we're multiplying this by 2. In order to make 6 18, we're multiplying it by 3. We're going to rewrite our new fractions here because we have already made a lot of a mess here. So our new fractions are going to be 3 times 5, which is 15, and remember this is still a negative. 3 times 6 will be 18. So it'll be negative 15 over 18 plus 2 times 4 is 8, and it's still negative. Negative 8 over 9 times 2 is 18. Our answer will have a denominator of 18. So now this becomes negative 15 plus negative 8. Again, negative 15 minus 8. Another way to say this. And again, you owe somebody $15. You owe somebody $8. What we can do is just add these two together, which will give me 23. It's still negative. So it'll be negative 23 18ths. And I'm going to check my math really quick, because I think 15 plus 8 is 23. But if you're not 1,000% sure, there's no harm in doing that. 15 plus 8 is 23. Okay. But we have ourselves an improper fraction. Numerator is greater than denominator. Therefore, we are going to divide 23 divided by 18. 18 will only go into 23 one time. When we subtract, we should have 7, correct? 5. I am not mathing today. So my correct answer will be 1 and 5/18. But remember, it was negative 1 and 5/18. Do 5 and 18 have any common factors? No, because 5 only has factors of 1 and itself, and 18 is not a multiple of 5. Therefore, our correct answer is negative 1 and 5/18. A lot going on here. Now we're going to have a kind of curveball here. Remember, according to PEMDAS, we do what's in parentheses first. So we're going to add 7/8 plus 3/11, and then we're going to add 1/8 into the mix. So I will teach you one thing, though. So 7/8 plus 3/11 plus 1/8. Okay, now, according to PEMDAS, we must do what's in parentheses first. However, there's a little bit of a scapegoat here, and that is that everything here is being added. Now, if this were multiplication in here instead, then yes, we would do exactly what's in here first. But because it is adding, we are adding. It doesn't matter the order in which we add. This number is being added to this number, then being added to this number. The parentheses in this case don't matter. We could add any way we want. So let's pick an example that would make sense. So let's say I have 1 plus 2 in parentheses, then I'm going to add 3 to it. 1 plus 2 is 3, plus the 3 later would make it 6. If the parentheses were not in place, it wouldn't matter because it's still all adding. So 2 plus 3 would be 5, plus the 1 would still be 6. The parentheses in this case don't matter since everything is being added. And remember, commutative property states that the order in which numbers are added or multiplied does not matter. Parentheses are going to play a big part when you have different types of math going on. For example, if I said 2 times 3 plus 1 and put these in parentheses, I would need to do the multiplication in parentheses first before I added 1 to it. That would need to be done. I don't know why the ruler's there. Or say I did 1 plus 2 times 3 and there was parentheses here. I would need to do this first. I wouldn't just do 1 plus 2 then multiply it by 3. The parentheses are going to dictate what needs to be done first. But again, the loophole in this is that this is all adding. Therefore, our answer is going to be the same no matter which way we add. And this question is set up pretty easily because, let me go ahead and just erase this, we have two like fractions already, 7/8 and 1/8. When I add these together, I'll have 8 out of 8, or I'll have 1. When I add 1 plus 3/11, it will just give me 1 and 3/11, and that is my answer. Now, if I wanted to do it the long way, I could, but it's going to be a lot more confusing. I would need to convert both of these to have the same denominator, which would be 88. Therefore, it would be 77 over 88 plus 3 times 8 is 24 over 88. Let's do this calculator. 77 plus 24 equals 101 divided by 8. 101, sorry, divided by 88 would be 1. Clear. 101 minus 88 would be 13. So this would be 1 and 13/88. 1 and 13/88. We'd have to multiply this by 11 again to add. So that would make 24/88. 24 and 88 would both have 4 in common, correct? Be 6. 88 divided by 4 would be 22. 4 out of 22. We divide these both by 2 again. Become 2/11. We did something wrong there. 13 plus 24. It's 27. Yeah. Either way, it would be a gigantic nightmare. And I even got lost here by trying to do this fast. So again, when it comes to examples like that, look for the easy way out. The parentheses are there, but it does not mean do these first. 7/8 plus 1/8 makes 1. Plus 3 and 11s. 3/11s makes 1 and 3/11s. I will try again. Okay, let's try one last time for this long answer. 7/8 plus 3/11 plus 1/8. If I did this like this, I'd have to multiply both by 11, which would be 77 over 88, both by 8, which would be 24 plus 88. 24 plus 77 equals 101 over 88. Now we're going to add 1/8 to this. I'm not even going to convert it yet. In order to make them both out of a denominator 88, multiply them both by 11. 101 plus 11 equals 112 over 88. Simplify that. 112 divided by 88 equals 1. 112 divided by 88 would be 1. 88 times go in. Subtract. This would be 112 minus 88 would be 24. 1 and 24/28. Sorry, 88. Divide them both by 8 this time. That's 3/11. That's what I did wrong. 3/11. Therefore, it'd be 1 and 3/11. And it's way more of a nightmare. Instead of just doing what we did, where it's 1/8 plus 7/8 equals 1 plus 3/11, and it's just 1 and 3/11, and we're done. Way easier. So that's the one thing I would suggest, is make sure you know the rules of the properties. Commutative property says the order in which we add or multiply does not matter. So parentheses in this case will not change things. Number 4, 4/5 minus 3/10. 4/5 minus 3/10. I can't make the 10 into 5 because I'd have to divide by 2, and 3 can't be divided by 2, so I'm going to upscale this by multiplying this by 2. 5 times 2 will become 10. We have our common denominator. 4 times 2 will become 8. 8 minus 3 will become 5. 5/10, and this is not simplified. So I divide both by, not by 2, divide both by 5, which will give me 1/2. 5 divided by 5 is 1, 10 divided by 5 is 2. Therefore, my answer is 1/2 on this one. Where are we? We're at number 5. 3/8 minus -1/4. 3/8 minus -1/4. So right off the bat, we're going to change this into plus, because when we're subtracting a negative, we're going to add. So it's 3/8 plus 1/4. I'm going to change this to be multiples of 8. Sorry, I'm going to change the denominator to become 8 by multiplying it by 2. This will also become 1 times 2, which is 2. 3 plus 2 equals 5. Denominator is 8. Correct answer is 5/8 because it's already simplified. And last but not least, 3/4 minus 1/3. 3/4 minus 1/3. Cannot do anything here, so I'm going to find a least common multiple between 4 and 3. If I count by 4s and 3s, it'll be 12. So I'm going to multiply this by 4 and multiply this by 3. These will both become 12. 3 times 3 will become 9, and 1 times 4 will become 4. 9 minus 4 equals 5. So it'll become 5/12. No common factors there. Therefore, 5/12 is my correct answer. And that's it. So remember, again, when you are going to add or subtract unlike fractions, we have to have them have a common denominator first. Common denominator needs to happen. Second, keep in mind the commutative properties. The order in which we add or multiply does not matter, even if there are parentheses involved. It's all adding, it's all multiplication. Ignore the parentheses. Find the easy way out. That big question where we had 3 numbers here, way easier if we just added the 1/8 and the 7/8 and it became 1. If you have multiple fractions that you're adding or multiplying, look for common denominators first. Look for like fractions first. And then don't forget that you always need to simplify your answer. This is Mr. P. If you guys have any questions, you guys know what to do. I'll catch you guys on the next one.